Welcome to section 4.3. We are going to start the basic idea of factoring. This is something that you did cover in Algebra 1, although seems to be an item that really asks us if you know your number sense or not. And so we're going to start off with some very basic ideas. First, we're going to talk about the different types of polynomials. The first one is called a monomial, and a monomial is something that has a single number, a single variable, or a combination of the two, and product means we're multiplying two together. Now let me show you some examples. One could be just simple 4. I could have a y, or I could multiply things together like 2x squared. And so this is kind of the idea of what a monomial is. It is one chunk of information. A binomial takes two chunks of information, so two monomials, and we basically add them together or take the sum. So I'm going to use the ones above and show you. We could have 4 plus y. We could have 2x squared plus 4, or the most common one we'll see this chapter is x minus 3. You know, something with a single x. So that's the first idea. Now again, you're adding two things together. A trinomial is the sum of, tri means 3 monomials. Okay, so as we're doing this, you could have something like things we've already seen. X squared minus 10x plus 25. Or 3x squared minus 7x plus 10. Something where you have 3 terms and then they're separated by either a plus or a minus. So you're adding or subtracting. Okay, now we're going to talk about basic foiling, and our goal is to basically unfoil is the word I'm going to use. So here's what's going to happen. Normally we'd give you something like this: x plus 2 times x plus 4, and we'd ask you to foil it. First times first means x squared. Outside, x times 4 is 4x. Inside, 2 times x is 2x. And the last 2 times 4 is 8. And what we would do normally is we would add these together. Okay? Now as we look at this, I'm going to put it back in standard form a second. We have an ax squared. These two together make up the bx. And then you have this c at the end. Okay, and our goal is to figure out, if I give you the ax squared plus bx plus c, how can you work backwards? So here's what we're going to do. We're going to look at this last term. We know that x squared comes from x times x. That's when we take our first x times x and we get our x squared. Then we're going to look at our last to see, is it possible that factors of the last number of c add up to the middle number b. So I look at 12. I could have 1 and 12, or 2 and 6, or 3 and 4. And as I look at these combinations, I say, can 1 plus 12 equal 7? Well, the answer is no, so I cross it off. Can 2 plus 6 equal 7? No, so I cross it off. Can 3 plus 4 equal 7? The answer is yes. What I'm going to do, because it's positive, I'm going to say an x plus a 3. So I take one x and group it with the 3. And I take the second x and group it with a 4. And because it's positive, I say plus, x plus 4. This is my factored form, it's what we call it, that if I were to FOIL this out, I would end up getting my original trinomial. So we're going to try one more. This gets a little bit more difficult because I add in the negatives. We always start with x squared, which we know comes from x times x. As we look at negative 27, let's just talk 27 to start. I could have 1 and 27, or 3 and 9. Now I know 1 and 27 have no way of getting me a 6, so I'm just going to cross it off to begin with. The 3 and 9 could get me 6. Now in order to get a negative 6, the bigger number has to be negative, the negative 9, because negative 9 plus 3 equals negative 6. So the x, one x goes with a positive 3, so an x plus 3. One x goes with a negative 9, so x minus 9. And if I were to FOIL this, I would get back to the original x squared minus 6x minus 27. And so this is the basic idea of what we're doing today. I'm going to make it a little bit more difficult as we go along in section 4.4, but for today, this is kind of the basic idea. So let's move up and we'll try another type. The second type that we're going to look at is called a difference of two squares, and they're going to give you this pattern, and I will show you the pattern, but I'm going to show it to you realistically as to what it means, and I hope that is a better way to look at it. If you get something that's called a squared minus b squared, so a difference of what we call squares, you can rewrite it in factored form as a plus b times a minus b. Okay, now we got to first talk about the fact of what is squares. If you think back to Algebra 1 and we talk about perfect squares, I'm going to go through the list of a few of them with you. The first perfect square is 1 squared, which is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared, 25, and I could keep going. 36, 49, 64, 81, 100. That's up to 10 squared. Okay, now you could go farther than that. And actually, you know what? I'm going to go 2 more. 121 is 11 squared and 144 is 12 squared. Those are probably the most common perfect squares. And so what we're looking for when we look at difference of two squares is to only have 2 terms, and each term has to be a perfect square. It has to be one of these numbers on the list. Okay? Now, here's what happens. I don't like the look of c squared minus 25 because there's no middle term. So what I'm going to say is c squared plus, there's no middle c, so I'm going to say 0c minus 25. And if you write it this way, we can actually go back to c squared is c times c. And how do you get 25? Well, the only way to get 25 is 5 and 5. Now, if I want it negative 25, one of those has to be negative. And if you look, what we said before is this negative 5 plus 5 should add up to the 0 in the middle. Since it does, it's c minus 5 and c plus 5. Okay, and that's really what a perfect square does without writing the 0 in the middle. But I like to put it in the middle just until you start recognizing what it looks like. So I'm going to do one more. X squared plus 0x minus 121. And I like writing it this way again because I want it to add up to 0 in the middle. Well, I know that x squared is x and x, and I know that 121 is 11 and 11. And because it's negative, one of these has to be negative. So as I look, negative 11 plus positive 11 does equal the 0 in the middle, which is good. So my two factors are x minus 11 and x plus 11. And the order that you write those doesn't matter. If you have plus 11 first, that is still correct. Okay? And so that's one type. It's called a difference of two squares. The third type that we're looking at is called a perfect square trinomial. It has to have 2 terms again. And the first and last terms, again, have to be perfect squares. And they have to also be positive. Okay? The middle 2 has to be 2 times the product of the first and the last factor. Now, I again look at this and go, that is completely messy. So I skip a lot of the rules and I just walk through it the same way. As I look at x squared, I know x squared is x and x. As I look at 49, I know 49 is 7 times 7. Now, can that add up to a negative 14? Well, no, it could add up to a positive 14, but a negative times a negative equals a positive 49. So as I look at this, I have the factor x minus 7 and x minus 7. Because they are identical factors, we want to simplify our answer. So we say x minus 7 quantities squared because there are 2 of them. So that's what's working there. Let's try one more. If I look at x squared plus 24x plus 144, I know that x squared is x and x. 144 is 12 times 12, and 12 plus 12 equals the 24 in the middle. So I have two factors, x plus 12 and an x plus 12, which ends up simplified version saying x plus 12 squared. Okay, and those are called perfect square trinomials. Again, I don't necessarily need you to know that that's what it's called, but more so how to use it. Okay, so let's flip to the next page and let's look at a few other examples. We want to talk a little bit more about factoring and when we use this, and I'm going to relate it back to section 4.1 and 4.2 as we talk about a graph. A quadratic equation is basically when you have y equals ax squared plus bx plus c. Okay? Now the biggest thing is a can't be 0. That's an A, I apologize. A can't be 0, or I don't have a squared anymore, which means it's not going to be a quadratic. So we consider this, like we talked in section 1, this is called standard form. We also learned vertex and intercept form, and I'm actually going to show you those two today as we go through. The roots of the equation, guess what? There's another word, are the same thing as the solutions. We also used the word zeros and intercepts in section 4.2. All four of those words are interchangeable. Okay? Now, the zero product property states, here's what it says. If I have that one factor A times another factor B equals 0, then either A has to equal 0 or B has to equal 0. One of them has to equal 0 in order to get 0 as an answer. Okay? So here's how that works. And we did this in intercept form in section 4.2. I can set each chunk equal to 0. So we call them factors. X plus 3 equals 0 and x minus 5 equals 0. And therefore I can solve each of these to say that x could equal negative 3, or if I add 5 to both sides, x could equal a positive 5. Because I have two factors, I should get two solutions or two roots or two intercepts or two zeros. So let's try using this zero property once we factor. So what I'm going to do is I'm going to try and factor this first one. I know x squared is x times x. I know that 15 is 5 times 3. Now one of these has to be negative in order to get a negative 15. And since the answer in the middle, the b is negative, then the bigger number has to be negative. So I have these factors, x minus 5 and x plus 3 equals 0. Now we just did this above, so I'm going to save us a little bit of time, because if you look, these factors are the same thing that is here. So this tells us that x equals 5, or this tells us that x equals negative 3. Okay, so I have two solutions. Now, I'm actually going to skip to number 3. You always want x squared to be positive. Okay, so I'm going to move over the 18x and the 81 at the same time. So I'm going to subtract the 18x and add the 81 so that I get 0 equals x squared minus 18x plus 81. Now, as I look at this, let's factor it again. X squared is x and x. 81 is 9 times 9. But in order to be a negative 18, both 9s have to be negative. So I look at this and I say, okay, I have x minus 9 and another x minus 9. And we would normally suggest that you write x minus 9 quantities squared. But as I look at this and I factor, this is x equals 9 if I set it equal to 0, and I'll show you that one here. X minus 9 equals 0. When I add 9, I get x equals 9. Do we need to say the same solution twice? No, we only need to say it once, so you really only have to do one of them. Okay? The last type is something a little different. You will notice that there are not 3 terms. So what I want to do is I want to look at what's in common, and I'm going to take out what's in common between the 2 factors. If you notice, the x squared and this negative 6x both share an x. If I take 1x out of the x squared, I have 1x left. If I take an x out of the 6x, I have just a 6 remaining. What I'm going to do then is set the first x equal to 0, and there's no solving, so that's my solution there. And the second one, I'm going to set that equal to 0, and I solve to get that x equals 6. So I have my 2 solutions, x equals 0 or x equals 6. Okay, so as you're going through, this is kind of the idea. Now let's relate this back to section 4.1 and 2, and let's talk about the graph. A 0 of a function is the value for x, which makes the function, let's do it this way, the function, and I'm going to shorthand this, equals 0. Okay, zeros are the same as its x-intercepts, and we talked about that above on a graph. So what we're going to do is we're going to factor it first and find the x-intercepts. And then I'm going to relate it back to section 4.2 to show you then how to find the rest of the information to be able to graph. So let's factor it first. X squared is x and x. Negative 28. Well, to get 28, it's 4 times 7. One of these has to be negative, but because the 3 in the middle is positive, the bigger number is going to be the positive one, so negative 4 is what we're looking for. So I'm going to find the zeros, and I'm going to put it as x minus 4 and x plus 7. And I'm going to set both these pieces equal to 0. And x plus 7 equals 0. And I'm going to solve this. To save us some time, I'm going to say, okay, x equals 4 and x equals negative 7. So these are my 2 x-intercepts. What I can do now is look at a graph, and I can go to negative 1, 2, 3, 4, 5, 6, 7, and I can plot a point, and I can go up to 4 and plot another point. And these are my 2 x-intercepts. Now, according to what we did in section 4.2, if this is intercept form, then I know to find the x-coordinate of my vertex, I take p plus q and divide it by 2. So I'm going to do that a second to be able to find my vertex. I take 4 plus negative 7 and divide it by 2. 4 plus negative 7 is negative 3. Divide it by 2. If you like negative 1.5, that's fine too. In order to find the y-coordinate then, I plug it back into my factored form. I think is easier. So I say negative 1.5 minus 4 times negative 1.5 plus 7. And if I find these two and multiply them together, what I end up getting is negative 30.25. Now, at negative 1.5 and down, let's say here's negative 30, I'm just going to shorthand this the minute I get this parabola with a vertex at negative 1.5 and negative 30.25. Okay. Excuse me. To save us a little bit of time, I'm just showing you, but I wanted to relate this back to what we did in section 4.2. So let's go same thing in number 2. X squared is x times x. 36 is 6 times 6, but they're both negative in order to get a negative 12x. So I have, and I'm going to put these together as I look at this, x minus 6 and another x minus 6, which means I have x minus 6 quantities squared. Now, I'm going to add a plus 0 at the end, and the reason I'm doing this is now vertex form. So we had intercept form here, and now we're looking at vertex form on the other side. The vertex should be able to tell us that immediately my vertex is at the point 6, 0. And I can make my graph then and find this. Because these two are the same, that means the only place it touches on the x-axis is right there, and I can kind of make this general parabola. Now, you could actually go through and find points, but I just want to at least get general look. So I know this is kind of a lengthy video, and we've put a lot of stuff in this, but I want to be able to relate everything we're doing in this factoring back to the graphing that we did in the first two sections to make it click. So that's the end of section 4.3. Thanks for watching.